In the previous lecture, we learned about how to graph sine and cosine functions. Both sine and cosine functions are wave functions, which oscillate between -1 and 1. The period of both functions is 2 pi. There is another important notion which you have to know when you graph more general version of sine and cosine function. That is amplitude. Amplitude is defined as the differences between maximum and minimum divided by 2. In both cases, if you think about the maximum value, then that is 1, and minimum value, that is minus 1. If you think about the difference, then the difference between maximum and minimum is 2. If you divide by 2, then you will get an amplitude 1. So the amplitude of the basic sine and cosine function becomes 1. But if we think about the vertical stretches or compression, then the amplitude will vary. And if we do horizontal stretch or shrink, then period will become larger or smaller. Y equals a sine of kx and y equals a cosine of kx is more general version of sine and cosine functions graph. What is included geometrically in this equation is by multiplying by k to x, depending on the number, it can be horizontal stretch or shrink. And by multiplying by a, we can stretch the function vertically or shrink the function vertically. Depending on whether a is negative or positive, it may indicate reflection along x-axis. If k is positive, then there is no reflection. But if k is negative, then there is a reflection along y-axis. Let's summarize that. Y equals a times sine of kx this a is multiplied to the entire function, so it changes the y value. So it also changes the amplitude, how tall the graph can be. If a is multiplied, then the amplitude is absolute value of a. If the absolute value of a is greater than 1, then it's like 2, 3, which is greater than 1. Then that is a vertical stretch. So the graph will become taller if the absolute value of A is greater than 0 and less than 1, then that is vertical compression. K is multiplied to X, so that affects horizontal things. If K is between 0 and 1, then that is horizontal stretch. What you have to be careful here is whenever that is related to horizontal thing, x-related thing, then your intuition will tell you opposite. If smaller number is multiplied to x, then that is horizontal stretch, meaning the graph varies slower. If k is greater than 1, then that means horizontal compression, meaning the graph varies faster. Period formula is 2 pi divided by absolute value of k, which is very important to remember. Indeed, if you just think about the period formula, then k is in the denominator. So if smaller number is in the denominator, then the entire fraction will become larger. And if the larger number is in the denominator, the entire fraction will be smaller. Depending on whether A is positive or negative and K is negative or positive, it determines whether that is reflected along x-axis or y-axis. If we multiply by negative number to the entire function, then y value will change its sign, meaning what was positive value will be flipped to negative value, and it should be flipped along x-axis. Since it is reflected along x-axis, that is a vertical reflection. If k is negative, that is multiplied to x, so it'll switch the x value, so positive x value will become negative x value, so we have to flip along y-axis. Since we flip along y-axis, that is a horizontal reflection. Here we discussed the period formula. Period was 2 pi over absolute value of k. In the previous lesson, I talked about the notion of key points. What I said was key points divide one period into 4 equal intervals. So the first benchmark will be 2 pi over absolute value of k times 1/4. And the second one is 2 pi divided by absolute value of k, which is period times 2/4. The third one is 2 pi divided by absolute value of k times 3 pi over 4. So what you have to do is just multiply by 1/4, 2/4, and 3/4 to the period. The reason the key points are important is whenever it passes the key point, it becomes either 0, maximum, or minimum. When you graph, the very important ingredients you have to consider will be amplitude, and period, and key points. Let's work out examples. Find the amplitude and period of the function. And then sketch the graph of the function. Let's consider y equals cosine of 2x. Let's consider the amplitude. If you look at the given function, then there is nothing multiplied to the cosine. So that means the maximum and minimum will not change. So the amplitude will stay with 1. Or you can say if cosine of 2x can be rewritten as 1 times cosine of 2x. So you can say amplitude is 1 if you are algebraic person. Period is 2 pi divided by 2. Both amplitude and period are positive numbers, so you can just forget any negative sign. In this case, the problem is given with positive number, so you don't have to be careful. That is pi, and we have to think about key points. I said key points divide one period into 4 equal interval. So that is pi over 4, 2 pi over 4, and 3 pi over 4. 2 pi over 4 is pi over 2. The reason we are thinking about the key points is there is a pattern of the cosine function within one period. It starts at the maximum and go down and go up to the maximum. When you graph, the first thing you have to think about is amplitude. Amplitude is 1, so the maximum value will be 1, and the minimum value will be -1. As I said, we will follow the pattern of the function with modified period. So one period is pi. We start at 1, then go down and up to the maximum. Just the pattern continues because this is a periodic function. This is the completed graph of y equals cosine of 2x. Second question is y equals minus sine of 1/2 times x. If we think about the meaning, geometric meaning of minus multiplied to the function, then that is flip along x-axis because we are switching the y value, the sign of the y value. As we did before, we have to think about the amplitude. amplitude is the number which is multiplied to the entire function. In this case, the number which is multiplied to the entire function is -1. So absolute value of -1 is 1. And period was, by its formula, 2 pi divided by absolute value of 1/2, which is just 1/2. Unfortunately, this is the number over fraction, so we will use the principle a/b can be written as a times 1/b. So this is a numerator, and this is the reciprocal of denominator. In this case, in the fraction, the numerator is 2 pi and the denominator is 1/2. So we can multiply 2 pi by the reciprocal of the denominator, which is 2/1, which is 4 pi. We have period 4 pi, so the key points will be pi, 2 pi, 3 pi, 4 pi, obviously, because just 1/4 of 4 pi is pi, and half of 4 pi is 2 pi, and 3/4 of 4 pi is 3 pi. From here, by multiplying by 1/2, there is a horizontal stretch. By looking at the period, you can notice that the period becomes larger because that is horizontally stretched. It's twice bigger than the original one. And there is a reflection along x-axis. There are 2 steps to graph this function. In the first step, we will just forget the sign in front of sine function. So we will graph y equals sine of 1/2x. In the second step, we will graph y equals minus sine of 1/2x. So at this stage, what happens will be horizontal stretch. In the second stage, we will flip, so it'll be vertical reflection, or reflection along x-axis. The maximum value is 1 and minimum value is -1 because we already know that the amplitude is 1. The benchmark happens every pi. We are thinking about the sine function, so we have to start at 0. This is the graph of y equals sine of 1 over 2x. In the second step, we have to flip along x-axis because of this minus sign. So 1 will become -1 and -1 will become 1 and so on. But zeros will stay as it is. This red graph is the final answer. Y equals minus sine of 1/2 x. The next question is y equals 3 times cosine of 2 pi x. Amplitude for this graph is 3, and 2 pi is multiplied to x. That changes the period of this function. Period formula was 2 pi divided by the number in front of x without any sign. Then that is 1. Always keep in mind amplitude and period are positive numbers. Key points: divide the interval into 4 equal intervals. So this is easy. 1/4, 2/4, which is 1/2, and 3/4, and 1. There is a vertical stretch. Maximum is 3 and minimum is -3 because of this amplitude. Let's mark at the benchmark key points. This is about cosine, so it starts at the maximum value and it'll follow the original function's shape. This is the final graph. Y equals 3 cosine of 2 pi x. The next question is about y equals 4 times sine of minus 2x. Amplitude of the function is this number, so amplitude is 4, and period is 2 pi divided by the absolute value of this number, meaning just a drop minus sign. So over 2, which is pi. We think about key points. Key points are zero, pi over 2, pi over 4, pi over 2, and 3 pi over 4. Just multiply by 1/4, 2/4, 3/4. This time there is minus in front of 2. The meaning of that is there is a horizontal reflection, meaning the flip along y-axis there are 2 steps we have to follow. Step 1 will be we will draw y equals 4 times sine of 2x without flipping, because we just want to follow the pattern of the original sine function. Then in step 2, to finish the problem, we will flip along y-axis. I said this is the original pattern of sine function. Let's do that. The maximum value will be 4 and minimum value is minus 4 because amplitude is 4. Benchmark happens every 1/4 pi over 4. Pi over 4, pi over 2, 3 pi over 4, and pi, and 5 pi over 4, and minus pi over 2, pi over 4, and minus pi over 2. We want to graph y equals 4 times sine of 2x. There is a vertical stretch and the horizontal shrink, but the pattern of the wave will be exactly the same. So we will follow the pattern of this function. It starts at 0 and go up and make wave. This is the graph of function y equals 4 times sine of 2x. To finish the problem, we have to flip along y-axis. So we flip along y-axis, so this point will move here, and this point will move here. And when you move the other way, it'll essentially switch y value. That's because sine is an odd function. So this -1 will be on the right side, and so on. So this graph is y equals 4 sine of -2x.